The sky, the stars, the universe. Since ancient times, people have looked up the skies and wondered about its mysteries. With the assistance of technological tools, we have been able to look beyond what we ever imagined before. Two of those powerful tools are the Hubble and the James Webb Space Telescope. Using these telescopes, we look into the skies and unveil the cosmos and its mysteries. Uncovering the mysteries of the universe will not be as simple as observing and taking note. As we look through the stars, we saw phenomena that we only previously speculated about. One such phenomenon is gravitational lensing. Albert Einstein speculated about the idea of gravitational lensing in 1912, but deemed it unobservable. However, after talking with Ruud Maldo, Einstein officially published about the phenomenon in a brief article in the journal Science in 1936. It seems like it wasn't until Einstein officially published and recognized gravitational lensing that the research for it started to take off. However, it wasn't until 1979 that gravitational lensing was officially observed. But what is the phenomenon of gravitational lensing? Analogous to a magnifying glass, gravitational lenses collect and magnify light from distant sources. The light of the source is distorted and magnified. Instead of using a glass lens, the effect is caused by the objects with hugest amount of matter. Take for example the Hubble telescope and a very distant star. If nothing was between the two objects, the light of the star would be so faint that the Hubble might not be able to see it. However, let's say there is a galaxy cluster between the star and the Hubble. The path of the light from the star, when passing around the galaxy cluster, will be redirected, creating multiple images of the distant star as seen by the telescope. So, it's a phenomenon regarding the bending of light. But why is it so important? Gravitational lensing is a powerful tool that allows us to see distant stars and galaxies that would otherwise be unobservable. This allows scientists to obtain more information about the universe. It was thanks to gravitational lensing that we were able to see our little morning star, Earendel, the farthest star seen up to date. Don't let this little pixel fool you. Sitting at a whopping distance of 12.9 billion light-years away from Earth, Earendel, as a giant blue star, is estimated to be at least 50 times bigger than our own Sun. Located in the Cetus constellation, Earendel and its host galaxy, the Sunrise Arc, were observed because of gravitational lensing. Estimated to be now at 28 billion light-years away, this star tells us information about the early universe. After reaching out to the discoveries of Earendel, the lead researcher and one of the co-authors shared their thought about the discovery and gravitational lensing. Lead author and discovery, Welch, explained where the inspiration for the name comes from.
Being the one who discovered it, I got the chance to name it. So I went with Earendel, which is the Old English word meaning morning star. The main sort of explanation is that this is in a time period in the universe that we refer to as cosmic dawn. So I thought that a morning star reference was pretty fitting. I'll also admit that I am a huge Tolkien nerd, and the character in J.R.R. Tolkien's The Silmarillion, Earendel, is also based on that same Old English word. So I will admit that was my original inspiration, was the Tolkien character, and then as I dug deeper, the Old English word just fit so well that I really wanted to stick with it.
He also talks about how long the discovery of the star took.
All told, from the first moment that we sort of started to have an inkling that this was a gravitationally lensed star to the paper actually coming out was probably about a year and a half. It was a long process of double checking our models, trying to make sure that we really understood what we were talking about. It's the old adage that extraordinary claims require extraordinary evidence. We really wanted to make sure we had really solid evidence before we published the paper.
Dr. Paola Dimauro, co-author and discoverer, expressed the emotions of discovering the farthest star to date.
Well, at the beginning, I didn't really believe it. I mean, let's be honest, it's a bunch of pixels at the beginning. And then you see it, you start to see the spectral distribution, and then you compare with models, and you see that that emission is really close to a star. It's it's exciting.
Discovered using the Hubble, people are excited for the James Webb Space Telescope. Dr. Dimauro shares a little bit of where she thinks the future research on gravitational lensing is heading with the addition of the James Webb Space Telescope.
Recently, also thanks to JWST, we are learning a lot because it allows you to see things that otherwise you won't see, right? In this case, we found these stars super far away at such a redshift that is exciting. It's opening a door towards an epoch that it's hard to really study otherwise, right? So it's exciting. So because you can see things that otherwise they would be too faint, too far, and to be honest, to see a single star was touching. I mean, it's a single star of a galaxy at that redshift, so and you can see it. So that was an experience.
Research is still being done to determine if Earendel is in fact a single star, or more accurately explained by models as a binary system. As a closing statement, Welch explained how powerful of a tool is gravitational lensing.
It's incredibly important. Just recently, the James Webb Space Telescope has started taking its first data. It's been going on for a few months now, and what we've seen already is that we're able to resolve things with the Webb telescope plus gravitational lensing that would be, essentially impossible to see without it. So it really does unlock a new view of the distant universe, especially. You can see objects that are, incredibly small. There have been a bunch of different analyses out of gravitationally lensed galaxies already that are, showing star clusters in these lensed galaxies that are the same size as things that we would see in the Milky Way and our nearest neighbors. But now we're able to observe them out halfway or further to the beginning of the universe. So we're really pushing the boundaries of what we can see. And that's all thanks to gravitational lensing. Without that, if we didn't have that as one of our tools, then there'd be no way that we could possibly do this.
In conclusion, gravitational lensing is a powerful tool that helps scientists to learn more about the universe. By having multiple images of the same source, scientists are able to obtain more accurate information about it. As we continue to search through the stars and uncovering the universe and its wonders, our technology will continue to advance alongside our knowledge. And who knows what exciting new mystery we will find the next time we look up towards the stars.